Now, first we will begin with our transaction class, and inside our transaction class, we have to. It should be derived from the UVM library class, which is UVM sequence item. So I will just write class sequence item. So I am this is a user defined name sequence item, and it will extend UVM sequence item. So UVM sequence item is an object. So there are two types of classes in UVM: objects and components. The objects are dynamic, so uh, throughout the entire runtime there will be there can be multiple instantiations of that object, and the components are not dynamic, they are static, so they remain as a single entity throughout the runtime. So here inside the transaction, I will just mention, like the regular test bench, I will just mention all the signals of error. So as you can see that there were three signals, two inputs of 4 bits each, and a single output of 5 bit. So I will write it right here, and I have to declare it as rand so that it could be randomized. But for the output, it should not be randomized, of course, because output will only be observed by the scoreboard or monitor. So let's just write. Uh, let us just write. Oh yeah, I also forgot to mention the data type. It should be bit. Yeah, it can be bit or it can be logic. I will use logic. And the output was of 5 bit. So after declaring the signals, the very first thing I will do is that I will create uh, a constructor, and that constructor will call the parents constructor, because if you will look out for this inside the library, you will find that the constructor of this class has argument. So in object-oriented programming, in system verilog specifically, if you have a parent class, and if the constructor of parent class has some formal arguments, then you have to explicitly call the constructor of the parent class. So for that reason, I will write the constructor of this class, and there is an argument, and you can look out for that argument inside the UVM libraries. And for this, I will just write that argument, and it should be of string type, and it is path, or you can just write it name, whatever you want to write. And I will name it same as I have mentioned here, right here. And inside the constructor of this class, you have to explicitly call the constructor of the parent class, and that can be done using super method. And inside that, you have to pass the argument name. And Now the last thing I will do is to perform the factory registration, which is very important for lots of things, and there are lots of things such as the print method and etc. So I will explain that in details after we create the complete UVM testbench environment. So let's just go ahead and use uh, the registration method. So for this, and not only the print method, you can also do the override, the verbosity override, the severity override, and etc. So I will just begin with it. So for to do that, you have to write tick UVM, and since sequence item is the object, so we have to write object utils begin, and inside that you have to write the name of the class which you want to register. So you could just have used UVM underscore object underscore utils, and just by using this you could have registered the class into the UVM factory. But since this class has some variables, it is better to use the UVM object utils begin and end, because in that way you can also register the variables which are mentioned right here, and then you can do various things, such as you can just go ahead and use the print method that will print the entire value of the variables of that class in a tabular form. So let's just go ahead and register each variable, and to do that you have to write UVM underscore field underscore int, and inside that you have to write the name of the variable, and then the I mean whatever thing you want to do. For this example we will keep it UVM default, and for later examples and for later test bench I will explain it even in more details. So we could also use various other things. So let's just stick to UVM default for this time. I will do the same for the other two variables. So by this method we have successfully registered the entire class as well the variables here to perform certain operations. So this concludes our transaction, and you can just also write constraints if you want, but since the main motto of this playlist is to understand the structure of the entire UVM environment in the simplest form, so we will just stick to we will just avoid writing any constraints. So this concludes the transaction or the sequence item for our design that will be used in UVM based verification.